Okay, so today we're going to review one of each type of problem. This is a fence problem to start with. It's number 6 from the notes packet that we've been doing. It says you had a rectangular lettuce patch, 480 square feet in area. So, area equals 480 square feet. It's going to be fenced off to protect it from rabbits. Find the least amount of fencing required if one side of the land is protected by a barn. So the only sides we're going to worry about are, we call this width and length. That's all I got to worry about. The barn is the other piece. Okay. I'm trying to find the minimum amount of length around that. Okay. So I'm going to call that perimeter, although it's not technically a full perimeter because we're missing a piece. But perimeter is going to equal 2W plus L. I just added up these three numbers here. Okay. I also know that area equals length times width. So in this case, 480 is length times width. And my goal is to minimize my perimeter. So that's what I want to start plugging stuff into, is this equation here. So I'm going to replace the L because it's kind of by itself. So length is going to equal 480 divided by W. So I will have my perimeter equals 2W plus length, which I'm going to replace length with this value, 480 divided by W. Okay. So I have that. That's what needs to be minimized. That's what needs to be minimized. Now, you can use your graphing calculator. I'm going to be fancy, and I'm going to use Desmos. And so for Desmos, the equation is 2W, or W is my x, so 2x plus 480 divided by x. Okay, so that has been graphed, and so what I'm going to do is I'm going to come over here and look and see if I can find it. There we go. So I'm looking for the minimum amount, which means I can just click right there. I get 15.492. So in my graph, x equals 15.492, and y equals 61.968. So now I have to make sense of what those dimensions are. Okay, well, it wants to know the minimum amount of fence required. This right here, the y value. Y is the output. It's my P, my perimeter. So this is the length of fence I need. That's the smallest amount of fence I could use to still get my area of 480. Now, X is W. It's my width. Okay, so this is 15.492. And so if I want to figure out my length, I have two options. I could say this equals 61.968 and then subtract 2W. That would work fine because this is W. What I'm going to do is I'm going to say 480 equals length times width, which is length times 15.492. And then just divide both sides by that 15.492. That's all I'm going to do. Okay. And so 480 divided by 15.492, I get 30.98. So my width is 15.492. My length is 30.98. And if they asked me for area, which they didn't, or length, total length, they didn't, but the total length would be 61.968 feet in this situation. Okay. let's try another one here. So that was how we do our thin's problems. Thin's problems are normally going to combine area and perimeter. Now, perimeter is always going to shake you because sometimes there's lines in the middle and stuff, but I call it perimeter sometimes. Now, an open box will be constructed with material that costs $7 per square meter for the sides, $13 per square meter for the bottom, and it has no top on it. It's an open top. So I'm going to go ahead and add a line right here so the box actually looks open. That way it makes sense to me in my brain. And I know the bottom, so the area of the bottom is going to be, well, it would be length times width, but in this case, I got 2x and x. So the area is going to be 2x times x, which is 2x squared. And so the cost of the bottom is going to be the price they said, which is, for the bottom, it's $13. So 13 times 2x squared, which is 26x squared. That's the cost for the bottom of my box. Then for the sides, I actually have 4 sides. So I'm going to kind of color those in. So this side here is the same as this side on the inside, which you can't really see very well. Those sides are the same. And then this back side is the same as the front side. Those 2 sides are the same. Okay, so once we find the area for 2 of them, we can just double it and find the area for the rest. So the area here is going to be 2x times y, because this is a y height. This is going to be xy for that area. And so the area for my sides is going to be 2 times 2xy plus 2 times xy, which gives me 4xy plus 2xy, which is 6xy. So there is my area of my sides. Now the cost of the sides is going to equal the area times 7. So it's going to be 7 times 6xy, which is 42xy. So now we have our cost of the bottom, which is right here, and our cost of the sides, which is right here. And they said, what's the largest box you can build? Largest box, that means volume, with $300. So my total cost is going to be the cost of the bottom plus the cost of the side, which is going to be 26x squared plus 42xy. And we know that that has to equal $300. So this is a big equation for us right there. That's a big equation. So we've got to combine that with our volume equation because we're trying to maximize volume. So volume is going to equal, well, in this case, it's length times width times height, which is 2x times y. So my volume is 2x squared y. Now, we don't know what y is, but we can find y. All we have to do is solve this equation for y, get y by itself. So I'm going to take away 26x squared, that'll be 300 minus 26x squared equals 42xy. Then I can divide both sides by 42x. And I'm left with, those cancel out. So y equals 300 minus 26x squared divided by 42x. You could simplify that sum, but honestly, you leave it like that, it works just fine too. So this is going to become 2